Parallel and perpendicular lines are things that you have studied in years past in geometry, but I doubt you've really looked at the equations for those lines and how they're related. So that's going to be our task for today. We're going to be writing equations of parallel and perpendicular lines. So first, starting with parallel lines, here is an example of two lines that are parallel. They have the same slope, but they have different y-intercepts, which makes sense because we know slope to be the steepness of the line. Those two lines have the same steepness. What they are different is that they have different y-intercepts. This black line is crossing at +2, whereas this blue line is crossing at -1. If they had the same slope and the same y-intercept, then they would be the exact same line. They both have a slope of 2/1, rise 2, run 1. So let's apply that in writing an equation for a parallel line. If a line passes through 3, -1 and is parallel to the graph of y equals 2x plus 3, what equation represents the line in slope-intercept form? So even though our end game, we're wanting to get that equation into slope-intercept form, that's not going to be where we start because we don't know the y-intercept. But here's what information we do have about this new line. We have a point that's been given right here, 3, -1, and we have the slope because we know it's 2. We've been told that it's parallel. Parallel lines have the same slope. So if we have a point and we have a slope, that guides us toward point-slope form. So our first step is going to be to substitute the values into point-slope form. Well, get my pen here. Okay, y minus y of 1 is going to be -1, so that's going to be +1, equals m, which is 2, times x minus the x value is 3. So now I've written it in point-slope form. I'm going to solve for y to transform it into slope-intercept form because that's the characteristic of it. Y is on a side by itself. So let's go ahead and distribute that 2 across. That would be y plus 1 equals 2x minus 6. And then I'm going to move that +1 over by subtracting 1 on both sides. So it is y equals 2x minus 7. Not too bad. Next, we're going to look at perpendicular lines. You can remember from years past that perpendicular lines, they intersect and they form a right angle, which you can see right down here. There's a lot going on in this picture. I'm going to try to point out to you what's happening. The red line and the blue line are your perpendicular lines. They are intersecting here at the point 2, 3, and that intersection causes 4 right angles. Now their slopes are not equivalent, they are opposite reciprocals. Let's think about some vocabulary terms here. Opposite is like if it was 2, the opposite is -2. So this opposite is meaning it's changing from positive to negative. Reciprocal, that is also known as the multiplicative inverse, like think dividing fractions, you keep it, change it, flip it. So reciprocal is like, that's supposed to be like an arrow there, ugly, but that's what it's supposed to be. Flip-flop of it. Okay, so let's take the red line here. The slope of the red line, it has a rise of 10, but a run of -5. So when you put that over it, 10 over -5 would be -2. So that is, well, you can see it right here. Right there, slope is -2. Whereas if you come over here, the blue line has a rise of 5 and a run of +10. And that would end up being 5 over 10, which would be 1/2 right there. So think about that. -2 and +1/2 are reciprocals of each other. -2 and +1 over 2. Because you could think of that as -2 over 1. It changed from negative to positive and it flipped over. So those two slopes are opposite reciprocals. So let's think about classifying lines. So here are two equations of lines. Y equals 3/4 x plus 7. We have no visual of this, just an equation. And 4x minus 3y equals 9. Is this parallel, is it perpendicular, or is it neither? So parallel would mean they have the same slope. Perpendicular means they have opposite reciprocal slopes, or if it's none of the above, then they would be neither. They're just two lines that intersect at some point. Since we need to compare the slopes to compare these two lines, which form is going to be best? Well, I'm going to go with either slope-intercept form or point-slope. Now, slope-intercept is going to win because y equals 3/4 x plus 7 is already in slope-intercept form. So then I'm only having to transform that one equation. You could turn them both into point-slope, but that just seems kind of scary too, trying to factor out that m there. And I mean, it can be done, but I definitely don't suggest it. So we're going to transform 4x minus 3y equals 9 to slope-intercept form. We do that by solving for y. So let's get to business on that. Let's get the 4x over to the other side because we want the y term isolated on a side by itself. So I'm going to subtract 4x on both sides. That's going to leave me with negative 3y equals negative 4x plus 9. Then I'm going to divide both sides by negative 3. And that cancels. Y equals negative 4 divided by negative 3. Those negatives cancel and make it positive. So that's just going to be 4 over 3x plus, and actually it's not going to be a plus, 9 divided by negative 3 is going to be negative 3. So there is the other line in slope-intercept form. Make sense? Okay. So let's look at them. 3/4 and 4 over 3. Do they have the same slope? No, that's different. We're comparing 3/4 and 4 over 3. Do they have opposite reciprocals? It's reciprocals, but it's not opposite. So it would be neither. Now let's go to writing an equation of a perpendicular line. So a line is going to pass through the coordinate 1, 8, and it's perpendicular to the graph of y equals 2x plus 1. Which equation represents the line in slope-intercept form? Same deal as before. Our end game, we want to end in slope-intercept form, but what information do we have about the new line? We have a point that's been given, and we can figure out the slope because we know perpendicular lines have slopes that are opposite reciprocals of the original line. The slope of the original line was 2. So the new line would have a slope of negative 1/2 because I would flip that over to its reciprocal and change it to its opposite. So we're going to substitute the values, these new values, into point slope form. So there's our point, 1, 8. We're going to use it. So y minus the y value of 8 equals negative 1/2, because that's the negative reciprocal of the original line slope, times x minus 1. So there it is in point slope form, and we're going to solve for y to transform it into slope-intercept form. That means that we're going to distribute that negative 1/2. So y minus 8 equals negative 1/2 x. Negative 1/2 times negative 1 would be positive 1/2. And to isolate y, we're going to undo subtracting 8 by adding 8 to both sides. That's combined with the 1/2 on the far end. Y equals negative 1/2 x plus 8 1/2. So there is the equation for our line that is perpendicular to the original equation of y equals 2x plus 1.